What's up YouTube? Mitch back with another tech tip here. I know it's been a while since you see my face. Hopefully I'm not too rusty for this. But today we're talking about something that's close to my heart, something that I've really loved and I've worked with for a lot of years, and that's Veeam. So what is Veeam? Well, it's a backup software that's probably, if not the most, it's very, very high on the most highly used enterprise backup software out there. And today what we're going to talk about is some of the newest features in Veeam 12.2. Spoiler alert, that comes with Proxmox support, which is the big reason why we're talking about it today. Obviously 45Drives is heavily invested in Proxmox, and it's really cool to see how quickly Veeam was able to say they were going to start supporting it and turn that around so quickly. So it's been really awesome to see that. And then secondary, after we go through all of the features and we kind of walk through step by step, adding a Proxmox cluster into your Veeam infrastructure and kind of how all that works, adding that backup proxy, etc. Then we're going to dive into how well our hardware and our software stacks really integrate with Veeam. And specifically what we're going to talk about today is how Ceph integrates really well with Veeam, specifically with RBD and XFS. So without further ado, let's jump on into it. All right, so like I said, we're going to do kind of two main pieces here today. The first piece is we're going to take a Proxmox cluster that we have, a 3-node cluster, and we are going to bring it into our Veeam backup infrastructure. We're going to go step by step. You're going to watch me do that. Once we have our Proxmox cluster into the Veeam backup infrastructure and we can see all of our virtual machines, then we're going to stop and we're going to move on to Ceph, and we're going to add in some new backup repositories into our Veeam infrastructure so we can start backing up our virtual machines. We're going to do this specifically with a Ceph cluster. And so what we'll do is we'll create a RBD, a Ceph block device. We'll mount that onto a gateway host. We'll put an XFS file system on it. And that gives us a lot of really cool features in Veeam, specifically Veeam Fast Clone. So what is Veeam Fast Clone? Well, it allows for a lot of really cool things, but one of the main things is really great dedupe, but also the ability to do instant synthetic full backups. So when you're doing backups, typically what you'll do is the first backup that you take is an entire backup, right? You're backing up the entire machine from start to finish. But after that, the days pass, the next day and the day after that, it's really inefficient to go back and do another full backup every time. So what you would have to do if you were going to do it that way is you're hitting your production storage that's running your virtual machine, and you're going to pull the entire image every single day. Even though from day to day, not a lot of data is going to change on that virtual machine, so it doesn't really make sense to do a full backup every single day. So what we do are called forward incrementals. So after you take your full backup, the next backup you do an incremental, and you take only the changes since the last backup, and that gets added into an incremental. So as you add these incrementals, what you have is your first backup, and you've got lots of little slices of changes. Now let's say you have a week's worth of those incrementals and your VM fails and you have to restore from backup. Well, before you actually restore, what you would normally have to do is you would have to take that full and all those incrementals and you would have to combine them into a new full afterwards. And so either by creating a synthetic one or by actually generating a brand new full with the original and all the changes. And that requires high I/O because you're taking a lot of data and you're moving data and writing new blocks. Where Veeam Fast Clone comes in and the the reflink module of XFS allows us to do is, rather than having to write new blocks for our synthetic full, we can just reference existing blocks. So we don't have to change, we don't have to move anything at all. So effectively you have your original image and all the changes that come across, and then what the reflink module does is just points at all of those blocks, where they are in place, and it forms a synthetic, a fake new full backup, so you can instantly restore your VM without having to actually rewrite anything. And that's a really, really cool feature. So that's one of the things that we heavily take advantage of with Ceph and XFS for our Veeam solution. Now, Ceph also supports object storage through S3, and so does Veeam in its newest release, or its newer releases. Now this is newer in Veeam, where they used to only support object storage in what they would call a capacity tier, which would mean you would have to back up actively to block storage or file system. And then from there, it could tier off to an object tier as like a secondary tier. But over the last, I believe, year at least, Veeam has allowed for performance tier, the first backup going directly to object storage. Now, in my opinion, the jury is still out on whether or not that's the best way to do Veeam right now. I would say still at this point, you're getting a lot more extra features and a lot of extra dedupe by sticking with block storage as your active backup, and then you could still use object tier as a secondary capacity tier. But it remains to be seen how things progress over as features come out. So that's kind of what we want to talk about. Those are the two things that we're going to go dive into today. So without further ado, let's go in and let's actually do this right now together. And you guys can watch me add a Proxmox cluster into our Veeam infrastructure first and foremost. All right, so here we go. So what we have up here is our Windows Veeam server ready to go. We have our Veeam backup and replication console up. I'm also going to show some other pieces that we have here. So we have our Proxmox cluster, as you can see here. This is a 3-node Proxmox cluster. 1, 2, and 3. We also have a gateway server that we're going to use as our Veeam backup repository node for our direct attached storage, but we're not going to touch that yet. We have that, and we also have Houston, which is our Houston UI for that backup server. So let's dive on in to our Veeam infrastructure first and foremost. And let's start adding in a Proxmox server first, and then we'll add the secondary and third ones. So the first thing you do is you go to your inventory page and you go to virtual infrastructure. Then we click on the add server, and what you're going to see is there's lots of options here. And this shiny new one that never used to be there before, Proxmox VE. So let's click on that. And so now we have to give it the IP address or the DNS name if you use DNS for your Proxmox server. So I will use host 1 first. 168.5.200, and it's going to go out and reach out to that guy once we give it some credentials. So you're going to give it the root credentials, same thing that you would do for ESXi as well, if you have ESXi virtual infrastructure you're looking to back up. So we're going to go root, and we're going to log in. And there we go. We can see its SSH fingerprint is there, so we're going to say yes, we trust this server. And so now it's going to validate, it's going to connect to our Proxmox infrastructure. All right, so we can see now this is the storage that will be used to save snapshots if the VM itself doesn't support snapshots. In this case, all of our VMs are going to support snapshots because they're all running on RBD, so it's all native snapshots, but we still have to pick a storage. Let's say if we created a VM and we wanted to put some local storage on it, and that didn't support snapshots because we were using LVM clustered or something like that. We would have to have a storage for it where Veeam could put snapshots somewhere. All right, so we're selecting the largest storage, which is going to be the CephFS pool it will use for that. All right, we can see that it's successfully registered the server. So now it's doing a refresh and we're ready to go. So now we can click next. We can already see in the background here that it is showing up. We can see my Proxmox cluster name, Proxmoxy, is popped up in there, and our first server is ready to go. So we click finish. So what you're going to see now is it's telling us that the Veeam backup server for Proxmox requires at least one worker that will deliver backed up data from the backup repositories. So what this essentially, well, what it exactly is a backup proxy. If you've used Veeam before, you may be familiar with backup proxies. So what we do is we create a VM on the Proxmox infrastructure for each host, and that VM is a worker VM. And what it does is it handles all the backup work for the Veeam server. So the Veeam server itself doesn't have to use all of its compute resources for backup. So what it does is it offloads all that compute to the VM does the work, and it just sends the data over to the Proxmox backup repository. So what's really cool about this is we don't have to go into Proxmox and create a VM manually. Veeam is going to let us do that. So let's take a look at how it does it. It's actually really cool. So we can see now we're going to give it a host name or an actual name for the VM. So let's just call it worker1. We're going to choose the storage. So again, we're using RBD for our storage, our block storage. So we're going to select our RBD pool. So by default, it's going to do max concurrent tasks of 4. If you wanted to, you could go to advanced, you could increase the number of vCPUs, you could increase the memory, and you could actually have more concurrent tasks. But what you may want to do, rather than trying to make one larger, wider worker, is just split it up to multiple. If you need more concurrent tasks, set up 2 or 3 workers on a host if you really need that much concurrent backup I/O happening, rather than having one larger backup worker or backup proxy. All right, so let's just keep everything default. 6 vCPU cores, 6 gigs of RAM, and 4 concurrent tasks. So now we have the ability to add a network to it. So let's go add, and you're going to see it has the ability to view all of your networks that are in your Proxmox cluster. So if I click the drop down, I have several different software-defined networks defined in my Proxmox cluster, and it can see every one of them here in the Veeam console itself. But we are going to use VMBR0. And we can see we can either let it use a DHCP to get an IP, or you could statically set the IP. For this case, we'll just use DHCP, no big deal. And then we click apply, and then it gives you a readout of what your VM is going to look like, the name, the storage. Essentially, it's almost like that very last page that you see when you create a VM in Proxmox, all of your summary of your creations. So we can see the thing that's checked down here is called test the worker configuration. When I click finish, something that makes sense to do. So we want to make sure it's actually going to work when we deploy it. So let's click finish, and now it's actually going to do that. It's going to spin up the VM, and actually let's take a look over here. We'll actually watch it live. So I'll drop down this for a little bit. We'll go over to our Proxmox environment, and we can see here VM 116 is being created. So there we go. Worker 1 just came online. We can see it started. So Veeam just created this VM for us in our Proxmox infrastructure. We can see the CPU usage is ramping up. So it is running its tests. It's making sure that it's working. Okay, so we'll go back to our Veeam infrastructure, and we can see, yep, it's still deploying it, which is exactly what we're viewing here. So really, really cool stuff. So once this finishes, we will click close, and then we'll add the remaining 2 nodes of our Proxmox cluster the same exact way that we just added this one. And again, we'll create 1 worker for every host. So we'll probably speed past that because the next 2 nodes are going to be exact same of what you just saw. All right, we can see it powered on the VM, configuration settings worked, obtained an IP address, everything looks good. All right, so we can see it's still going through its testing phase. So the connection was successfully established. So we can talk to the worker VM, and now it's checking the known repositories for updates. So we're almost through the finishing up the progress of the test here. So it should be done any minute. All right, so there we go. So we can see the connection was established successfully. Everything looked good. The VM worker was powered off after all the tests were done, and it says the worker was tested successfully, so we're good to go. All right, so now I'm going to finish up here. So now what I'm going to do is I'm going to run through and I'm going to add the 2 more hosts in this cluster so we can actually finish up, and we can already see many of our virtual machines here, but we can't see all of them because we don't have all of our hosts added yet. So that's what I'm going to do now. So through movie magic, we'll come back and we'll have all of them added. There we go, boom, all done. We're ready to move on. So we've got all 3 workers, we've got all 3 hosts. So we are now ready to start backing up our infrastructure, except for one tiny thing. We don't have any backup repositories, except for the default one that gets made by Veeam, but that's not something you'd ever really want to use. So we can see here, if we click on our Proxmox cluster, we can see all of our virtual machines that exist on this cluster. So we've got 2 Windows environments, and the rest are all Linux environments. So very, very cool. All right, so next step is adding some backup storage. So like I said, we've got a few different ways that we can do backup storage into Veeam. One of the ones that we're going to show off today is Ceph's block storage, RBD, Rados block device, with an XFS file system on it using the reflink module and checksumming. And so without further ado, let's do that. So first things first, I've got my little notepad to keep me on task here. So we can see we are now into part 2. So first thing we're going to do is we're going to create an RBD. So we could do this all through the Ceph dashboard, but I much more prefer the command line these days. So what am I saying these days? Always. So let's do some of that. So let's create a 2 terabyte RBD for our backup repository. It's just going to be a test anyway, so it doesn't really matter the size, but I think 2 terabytes is a nice good number. So RBD, actually let's just, before I do that, so this would signify a gateway host that would come with one of our clusters. We'd have multiple storage nodes all running the OSDs and the Ceph services, and then there would be 2 one-use, at minimum 2, one-use servers that sit in front of the cluster for gateway services. They would run things like the CephFS metadata server. If you're doing NFS, there'd be a highly available NFS cluster. If you're doing SMB, it'd be a highly available SMB cluster. If you're doing iSCSI, it would be our brand new iSCSI solution, which now has a Houston module, and I'm going to be teasing that right now because that's my next video. So definitely stay tuned for that because it is really, really cool. But I digress. So if you're doing anything like that, those where those gateway servers comes in. Also, for Veeam, as a Veeam backup repository, this is where we would put that RBD and then XFS file system as well. Now, if you're interested and you want to know how we might make this highly available, a Veeam backup repository with 2 gateways, so if that gateway fails, that Veeam automatically points to another gateway, let us know, and maybe I'll do a nice little cool follow-up video showing how to do HA XFS RBD volumes for Veeam. But, so let's see. So this is our server here. This is our gateway. So what we have on this machine is a Ceph conf file, the Ceph common packages, of course, so we can talk Ceph, and a Ceph keyring. So you don't need the admin keyring, of course. That's what I'm using here just for simplicity. But what you would do for best security practices is you would make a Ceph keyring specifically for this gateway that only had the privileges to read and write to the RBD pool or the specific RBD namespace that you would be using for your Veeam backup repository. That would limit the attack surfaces that anyone would have if they ever did somehow elevate into your gateway server. So if we see, we can run a ceph-s command, a Ceph status command here because this host has a Ceph conf, has a Ceph keyring, has a Ceph packages, so it can talk Ceph, it knows where to communicate, and it knows how to communicate to the cluster. So that means we can run Ceph commands here and it will talk back to the cluster and do it for us. So we can run an RBD create command, RBD the pool / the name of the image we want to create. So let's just call it Veeam repo -- size for how big we want this. We said we'd make it 2T and everything else will keep default. Instant, right? Because it's thinly provisioned, RBDs get created right away. So now that the RBD exists, it's created, but it's up in the ether. It's not mounted anywhere. It's not accessible at this point. So let's change that. Let's mount this RBD on our gateway host with an RBD map command, RBD the pool, Veeam repo, and we can see immediately the RBD with a kernel mount has been mounted to the device /dev /RBD0. So if we do a ls block now, we can see our boot drive, we can see we have a secondary drive SDB, and then we also have RBD0 2 terabytes. Wonderful. All right, so next step, let's create a file system, an XFS file system specifically, on this RBD. So makefs.xfs-m for our options here. So we're going to go crc equals 1, reflink equals 1 because we do need these enabled for Veeam Fast Clone. Now, I will say most versions of XFS these days, if you just do makefs XFS without any options, it's going to enable these anyway, but it's always nice to do it just to be sure. So we're going to make this file system on /dev RBD0. And so we can see it's making the file system, just scattering burning blocks. And when we look here, we can see it uses a 512 sector size. We could have, but did use a block size of 4K, which is what we wanted. But we can also see, if we take a look here, our CRC is enabled and our reflink is enabled. So we're good. We know we have reflinks on. Okay. So we have an RBD, it's mapped to the machine, we have a file system on that RBD. What's the next step? Well, we have to mount that file system to a local path on the machine before we can actually access it. So first things first, let's make a directory called mount Veeam repo. That's where we're going to put this. I guess it helps if you spell it right. Make dir Okay, so we made a local directory at mount Veeam repo, and now we are going to mount the file system to that location directly. So let's do that now. Mount-t xfs dev rbd 0, and locally to mount Veeam repo. All right, so now let's clear this. If we do a df, we can see we have a new mount point pointed right here directly on Veeam or mount Veeam repo, tying back to our RBD. Okay, we're getting closer, but there's a few things we need to do now. Because Veeam does not want, especially if you're doing a Veeam hardened repository, and which we'll talk about in a little bit, Veeam is not going to let us log into the gateway server where the repository exists with a root login. So what we're going to do is we're going to create a new user, and then we're going to add that user to the sudoers. And we'll just talk about what that is and what we're doing here. So let's start by creating a new user. So we could do it with user add, but let's go into Houston and make use of one of our Houston modules just as a little plug. So we're on our Houston UI right now in our gateway. And if we go to our identities module, this is where we can create new users and groups. So let's create a new user, and let's call this Veeam user. And we want their shell to be bash, so that's good. So let's click apply. And now it's going to make us put a password on this user. So I'm just going to do something simple, but you're probably going to want something complex if this is production, of course. All right, so there we go. So we have a new user created, and we have their password created. Okay, that looks good. But this user is not a privileged user as of yet. So let's go in and let's change that. Go back to this guy here. And what we're going to do is we're going to run the visudo command. And it's going to bring us into the etc visudo sudoers file. So what we're going to do is we're going to page down to what we can see, root here. And we want, in this case, we're just going to give this user all privileges. Again, something you probably are not going to want to do in a production environment. You want to lock down the privilege of this user to only be able to do what you need them to do. And so you're definitely going to want to look into exactly what you want that user to have privileges for and which directories they can read and write to. So for simplicity, we are just going to create our Veeam user, and we're going to give them all. There we go. So that gives this user super privileges. Now the last thing we have to do is, if you recall, we mounted our repo at mount Veeam repo. And if we do a ls-l here, we can see the owner of this directory is root. So if we go to our Veeam server and we log in as Veeam user, it's going to let us log in. But then when we go to actually write to that directory, it's going to look at it and say, well, I don't have permission to write there. So we need to change that. We're going to change the owner of this directory to Veeam user. So let's go chown Veeam user. So that's the user and group, and the local directory Veeam repo. So now if we do a ls-l, we can see that's now changed, right? So we can see the owner, the user in the group is now Veeam user. And what we should do, what I'm going to do is we're going to give the user and the group read, write, execute, and then we will give other nothing. So what we'll do is chmod 770 Veeam repo. So now we do LSL one more time, and we can see we have read, write, execute for user group, and then -- for other, meaning nothing for others. So that should be everything we need to do to configure on the gateway side, on the actual backup repository side. So let's head on back over into our Veeam server, and let's continue on. So now we're going to go to backup infrastructure, and we're going to right-click on backup repositories, and we're going to add a new backup repository. So there's lots of different type of backup storage you can add into Veeam. We can see direct attached storage. This always kind of confused me. They call it direct attached storage. In my mind, direct attached storage is not over a network. It's direct attached, right? Actually part of the server itself. But I guess in some way I do understand what they mean by this. But essentially what direct attached storage is doing, and it's actually quite cool. So if we have a Linux server like we do, our repository, when we add direct attached storage, what Veeam is doing is it's SSHing into that machine, and it's installing a Veeam data mover on that machine, and then it's communicating over, it uses several ports in the range of 2200 or so. We'll see here in a few seconds what range of ports it uses. So it uses a range of ports, but it uses SSH to make that connection to do Veeam data mover services. So let's dive in and see what we have here. Now, if you don't have XFS and you don't have RBD and things like that, you can use just regular old network attached storage as well. You're not going to get the same level of features, but you will be able to still do backups. So if you wanted SMB shares or NFS shares, you could do that as well. But we're going to get some extra functionality by doing it this way. So direct attached storage, and now we can see we have two options. We have Linux, add a local storage or locally mounted NFS share. We recommend using XFS, which we're using. And then we can see the one below, which is what we're going to use, and that's hardened repository. So this requires a Linux server with internal or direct attached storage. The configuration enables protection against cybersecurity threats with immutable backups. The Linux server must use the bash shell, which we are, and it must have SSH installed, which we do. For reduced attack surface, minimal Linux installation is highly recommended, which we also do. So we only install the packages that we require, and we also only open the ports that we need to open to make sure that we keep our server as low of an attack surface as possible. And so what this hardened repository brings to the table, additional to fast cloning, is immutable backups. So if a bad actor ever got into your infrastructure and tried to either encrypt your backups or delete your backups, they actually would not be able to, because they are immutable from the date that you take them to the date that you set. So normally you may set 7 days, 14 days, whatever it may be. And from the day that you set that, that data cannot be edited or changed, or deleted rather. So that's what we're going to choose. So let's click Hardened Repository. And let's call this Ceph RBD as our new repo. And now we're going to add this server. So let's go to the IP address is 10.10.10.51. And we're going to add our credentials for our user. So we can see it's a non-root account. So we're going to go Veeam user. Okay, so let's add that user in. So now it's checking the SSH connection. It's trying to log into our gateway server so we can make sure that it can communicate. And if it does, we can see, there we go. We see the fingerprint. We're going to say, yes, we trust that server. All right, we can see, so is it detecting previously installed components? So was this ever used as a Veeam backup server? If it was, then it wouldn't have to reinstall, but we can see this never has been. So we can see that the transport service is going to be installed and the installer is going to be installed. So these are Veeam data mover and transport services that will be installed on that machine from the Veeam backup server. So it's doing that right now. So let's let that happen. All right, so here we go. So we can see we've configured the transport service. They started it. Everything is installed. Grabs the database, everything is done. So it's got the local disk. So we still haven't chosen which directory we're going to use as our repository yet, but we're going to do that next. So let's click next. So now we can populate this server, and what it's going to do is going to populate the disk paths or the directories that are mounted on this machine. And there we go. So we can see Veeam repo is one of those, and there's that 2 terabytes. So that's what we're going to use. So we'll click next. And let's click populate once more, and we'll show the capacity here. All right, so there we go. So we populated. We can see we've got 2 terabytes. We've got 2 terabytes free. So we're going to say we're going to make our backups immutable for 7 days from the time that we back them up, which makes sense. And by default, you limit concurrent I/O to 4 tasks. You can increase that, especially if you have very, very high performance storage. So you can kind of play with those numbers as you start to do your backups and say if Veeam is really cool, because what it will do is when you're doing your backups, it will tell you where the bottleneck is. Is it the storage? Is it the actual VM side itself? Or is it the server, the compute? So you can kind of tell where the bottleneck's coming from, which is really, really helpful. All right, so let's click next. And we can see it's checking if XFS Fast Clone requirements are met. And of course, we know that they are, so it's going to pass this. There we go. Now it's validating its repository settings. Once we get past this, we're almost ready. Okay. So we can use a mount server. So let's read this. So it specifies a server to mount backups when performing advanced restores. So instant recoveries require a write cache folder to store change disk blocks on. So if we wanted to do an instant restore of a backup into our environment, what it will do is it will spin up an NFS server and use that as the storage that it's mounting the VM from, which is really, really cool. So we're going to do that, and we're going to enable that by default. And here we go. So we're going to click. So the one thing we could check here is search the repository for existing backups. So if there was any backups on this repo that was used before, you could do this, and it would actually import these backups into your infrastructure. In this case, it's a brand new file system, so there's no need to do that. We click apply, and it's doing its last little checks. All right, guys, so there we go. We can see our backup repository has now been configured successfully. So we click next, and we can see we do have our immutability on for 7 days. We have our XFS, we have our reflink, and our fast clone. So let's click finish. So do we want to change the default backup to our new created backup repository? Normally I would, but because I'm rolling this back all the time and changing it, I'm not going to, because it makes things harder for me. So I'm just going to keep this as not the default, but that would most likely be something you would want to do. Okay, so here we go. So we now have our infrastructure integrated into Veeam. We've got our backup repository integrated in Veeam. What's the next step? Well, to start setting up our backup jobs, right? So let's do that. So let's go to Home, and let's right click, and we can go to Backup here, and we can say, let's back up a virtual machine. You can actually also back up physical hosts as well with Veeam, which is really cool. So we can see you can back up a Linux machine, a Windows machine, a Mac computer, a Unix computer, and even application. So the way that they do that is they have things called Veeam agents. And so you'll install an agent on your physical host, and then Veeam will communicate with the agent and actually physically back up the host. So Veeam is just, it's fantastic. It's just so cool. But let's back up a virtual machine and show you how this works. So we'll call this a backup job. So this is something that's going to run at a set period of time based on however we want it to run. So let's just call this daily backup VM1. Not a very good name, but you get the idea. Okay, so now we add a VM that we want. So we can see we have one cluster populated here. Click the drop down, you click all your hosts. So let's back up one of our gateway hosts. So I'm going to click on GW1, click that guy. We can see the total size of this VM is 32 gigs. But what you are going to see is just because the VM itself is 32 gigs or the image is 32 gigs, that's not going to be the size of your backup because it's only actually going to back up the data that it requires. So what backup repository are we going to use? Of course, we're going to use our Ceph RBD. And let's keep our retention policy for 7 days. That makes sense to me. And let's click next. So we can see now, if we click this, we can go run the job automatically every single day at this time at 10 p.m. It makes sense for a lot of organizations to run their backups at nighttime when there's not a lot of applications or work going on. So there's not a lot of I/O happening on their storage at that time. So let's do that. We'll run it every time at 10 p.m. But what's really cool is, well, it's not 10 p.m. now, but I do want to run this backup job right now to show you guys. So watch. What I can do is I can click apply. So now it's going to create it so it'll run all the time. But we can see before we finish, we have a little check mark down here to say run the job when I finish. So that's great. So for our first run, we can run it right now. Then every time after that, it's going to run at 10 p.m. So let's do that. There we go. And so now immediately we can see a backup job running. I'm going to double click it, and we are going to watch it do its thing. So what's really cool is right now in the background, and you can see down here, it's preparing the worker. So if I head over to our Proxmox environment, you're going to see that worker 1 has now turned on, and we can see the CPU usage is ramping up here to 17% at this time, and it's going to go higher and higher. We can see 30%, 34%, even the memory is going to start ballooning because it's now doing a lot of work. And we'll go back to our Veeam environment here, and we can just wait, and we'll watch. Once the I/O actually starts happening, you'll see it here. All right, so our backup is just finishing up here. We're getting very close. So we can see, in this case, the bottleneck is the actual source, so the VM itself, not our backup repository. We can see that it's only actually transferred about 3.3 gigabytes, even though the VM itself is 32. And so we're just about 99% and we're almost done here. And I'll just wait one extra second for it to finish up. But yeah, we can see these different lines here. So we can see the transfer speed, the read speed of the actual backup, and the overall speed of 260 megabytes a second. So there we go. So our backup is now complete. That's going to run every day at 10 p.m. now, and it's going to do its forward incrementals for us with a synthetic full. And what's really cool is those backups are immutable, so they can't be deleted. All right, awesome. So hopefully you guys enjoyed that. We did a little bit of Veeam deep dive. We did a little bit of Ceph RBD deep dive, and we kind of brought them all together. So if you guys are interested, like I said earlier, in seeing how you might make this highly available so without a single point of failure, definitely let me know and we could do a follow-up video about that. Also, stay tuned for that HA iSCSI video and the Houston iSCSI video, because that's coming as well. And yeah, if there's anything else you guys are interested in seeing, definitely leave a comment down below. But other than that, we'll see you next time.